Up next is Al Scott with his 10-minute astronomy news update. Take it away, Al.
So I wanted to start us off with a bang. I don't know. You've probably all heard about this this meteor that exploded over Chelyabinsk. It was a stony iron meteor that came into the atmosphere. They've actually had a lot of footage from various cameras of this event. It's actually they've now recovered fragments. There's a 1 kilogram fragment. It was a stony iron meteorite, about 10% iron, and they've been able to work the orbit of this thing back using footage from various cameras. It's an Apollo class asteroid that came in. So we've got some video of it. So I just click, or do you want to do that? Imagine driving to work in the morning with your dashboard camera, and then you see that. Entering the atmosphere at about 18 kilometers per second, and glowing brighter than the sun. And here's the smoke trail of it. It actually there was a bit of a shock wave. There are multiple explosions. The explosion breakup was right directly over the city of Chelyabinsk, Russia. Over 1,000 people were injured by the glass. They actually were able to estimate the. Go back. Can you go back to the other slide? They're actually able to estimate the size of this from the infrasound, because they have infrasound listening posts set up around the globe, and the infrasound explosion carries, and they use these for monitoring nuclear explosions, and so the explosive energy of this was around 500 kilotons. This was the largest known bolide since the Tunguska event over Russia back in the early 20th century. So really a big event. They estimate that the asteroid was about 15 meters in diameter and weighed about 10,000 tons. And there was a hole in the lake ice. They haven't actually recovered any big fragments yet, but they're looking. So now go up the. Yeah.
I just heard Mitsu Keiku.
Mm-hmm.
He was on just the other night on Stephen Colbert, and it was a few seconds later. It wouldn't have been a shockwave in the air. It actually hit the ground.
Wow. Yeah.
It hit the ground with the equivalent to 20 Hiroshima bombs.
Yeah, it was a very low angle of incidence, and they figure it exploded about 20 kilometers up. That's why there was such a delay between the sighting and the explosion shockwave. So in rapid response, Canada sent up 3 satellites. Or 4, actually. The week after, to hunt for near-Earth asteroids. This is amazing, really. It actually was not related, but a very good publicity for Canada's satellites that went up on an Indian rocket, the PSLV. There's in the left here is a model of the Sapphire instrument, which was a D&D camera on a Surrey bus, and this camera was built The instrument was built by ComDev. The prime for the mission was MDA. And this is to actually look for satellites. It's a low Earth these are all polar orbiting now, around 800 kilometers altitude. And this one's to look up at the GeoArc and provide updates on the coordinates of these things to NORAD, who monitor all of these things and continually update the orbital elements of them. So this is Canada's contribution it's a military satellite to contribute to our part of NATO. The one on the bottom right is NEOSat. NEOSat is a combined DRDC science mission. So DRDC is a defense research establishment. It also has a mandate. Half of its mission is to look for orbital debris. The other half is to search for near-Earth objects, the NEO portion of the name. And the PI for this mission is Dr. Alan Hildebrand, who was a past president of our society here in Ottawa, actually. And this was actually it was supposed to be a build-to-print of Canada's most microsatellite. So it's very similar in size to the most satellite that's been up there doing astronomy. And this has got a big baffle. You can see the baffle pointing out at the end of it in the bottom right there, so that it can look very close to the sun and see asteroids that we wouldn't be able to see from Earth, where the atmospheric scatter of the sun's glow would make it impossible for us to see it. You have to go up into space to look very close to the sun to see these things on orbits that are interior to the Earth's orbit. There's very few of them that have actually been mapped because of this problem. You can't map them from the Earth. And in the upper right is the world's smallest astronomy satellites, the Bright constellation. And this is to look at very bright stars. And it's as you can see, it's a CubeSat. And there was two of them, and they're Austrian actually, but they were built by UTIAS, the University of Toronto Institute for Aerospace Studies. And they are they're going to stare at very bright stars and do astroseismology, measure the vibrations of these stars and learn about their interior workings. And there's going to be 4 of them in the constellation. There's 2 that were just sent up. So some interesting times ahead for Canada in terms of searching out asteroids and astronomy and cameras in space. So lots of interesting times ahead. Hopefully they're all working fine up there. Thank you.